Thank you for coming today. I know it's been very hard to choose which talks to see. There's so many things going on at the same time. So thank you very much. We're here to talk about live data beyond ViewModel. So we're not going to be focusing on live data. It's basics of live data of ViewModel very much. But actually, we're going to be talking about how powerful those tools can be and how you can use them to improve the code of your UI. But before we start, I wanted just to do a quick introduction about myself. My name is Marcus. I work as a software engineer for Android at Tinder. I'm also a Google developer expert, and I have almost 8 years of Android software development.
Hey guys, I'm Tasha, and thanks for being here. I've been at Tinder for 2 years now, and I've been developing Android for about over 5 years now.
Cool. It's 2008, and it's been 10 years that we have Android, and a little bit more that we have iOS. And we're trying more and more trying to solve issues and problems by using mobile apps. So they're becoming more and more complex. Over the years, we've got to many different patterns on how to solve issues, and they evolve according to the problems we've been facing. If we take the example of Tinder, for example, right here we have this functionality where when we change pictures, we also change the information that we're showing about that person on the bottom, maybe the anthem that they like on Spotify, the Instagram pictures, and all that. When we look on how this could be done, hypothetically, I'm not saying that's how it's done, but let's say if hypothetically, how could it be done? We have this section here where we can show information about the users. It could be Instagram, it could be a bio, it could be a description. Then when we go a little bit on the top, we have another container that needs to be able to switch those informations when we change pictures, right? Then we need another container to show the name of the person, the age, some icons, some other information, whether you have a Tinder U, for example, it's another feature, whether you have some country-specific features, and all that. When we go to the main part of it, the main card stack, you have all that inside of that, so we can have that container. And when you look into details, we could call this as a card container on top that actually has a content container there in the bottom. Then we have the headline text and the preview carousel, which is what changes the information that's inside there. And then we have the summary, biography, anthem, Instagram, and all those other information. But it doesn't stop there, because we actually have a page indicator here in the top, which is on the same hierarchy level as the card stack. And then we also have the whole carousel of the pictures that actually change the pictures when you tap on the right, on the left. So actually, this is what we have as a final product, just as a high level. And so from the card container until the pictures carousel and until the anthem, we have two different graphs of views and information. And when we're changing here, when we come in here and touching there and changing the pictures and all this information, we end up needing to have a communication between the pictures carousel and the previews carousel, so we can change those information when one can react to the other. But then you can ask yourself, what's the best way of doing that? Should we have listeners that just go back to the top and then go back to the bottom so it can change the information? Or should we use MVP? Should we inject something? So hopefully by the end of this talk, we'll have a very good solution on how we can do this right now. So fragments and views.
All right. So I think we can all agree that these things can get pretty complex, as we saw the view hierarchy that Marcus just showed. And just in general, simple apps can start with simple UI, and then they quickly build up and build up. And so we just wanted to sort of give you guys an overview of just wanted to talk about how most cases, you'll have a fragment, and then you'll have several child views. And usually the way you would want these things to communicate with one another is via listeners. I think that's the most common approach, and that's what we mostly tend to do. So we use listeners to communicate up from the child views to the parent, and we might also use them to communicate between the child views. Now let's take a look at what happens if you start adding activities to the mix and if you start adding more and more fragments. So let's say we have an activity. Let's say we have a few fragments going on. Each fragments have a few child views in them. And as you can see, like the more fragments you add, the more child views you add, these things can just sort of exponentially grow. And now comes the problem of how do these components talk to each other. So like the first layer, I guess, would be fragments talking to activities, fragments talking to one another, and then views, the child views of the fragments talking amongst each other, and then also with their parents, right? So this talk is not going to focus on MVP. We mainly wanted to bring this up to kind of showcase three major advantages that we think MVP has, and MVP is something that we use in Tinder, and we've been using it up until recently. So just show of hands, how many of you guys are familiar with MVP? Yeah, awesome. Okay, cool. So yeah, it's not. We're not going to introduce MVP to you guys, but we're just going to run through three important points. The first of them being views end up being bare bones. There's almost no business logic in there. In fact, if there is business logic in your view and you're using MVP, then you probably need to restructure a few things. Second thing, because the business logic no longer lives in the views, it has to live somewhere, and it ends up living in the presenters. And then the third thing, now that this business logic has been distilled to the presenter, it's easier to test. So this is well and good when you have a simple enough interface and a simple enough app. But let's see what happens when you want to use this approach with complex view hierarchies, right? At this point, a view group might contain several children, several view groups even, and that view group, those children might contain even more. So it just keeps going, and at that point, your main view, is it really that bare bones? It's going to have to talk to its children somehow. Secondly, presenters now will have to gain more and more responsibility because there will be more business logic involved with complicated hierarchies, and you're going to want to have to put them on the presenter because that's the pattern we've been following. And then the third point is that, so at this point, your presenters become monolithic. They're harder to test. They're harder to decouple. And without some further destructuring, they're going to become really hard to manage. And one of the core principles that we really wanted to drive in this talk is that UI is intrinsically reactive. It wouldn't be UI if it weren't reactive, right? So let's take a look at a very basic example. Let's say this is a screen with 3 buttons on it. Let's say I start clicking on one. Something happens on the screen. I click on something else. A few other things happen on the screen. When I click on the third button, the screen has changed in a wholly different way, right? So UI is reactive. On Android specifically, like we do this a lot where we have to change the layout parameters of views and perform other intricate manipulations with the view, and we usually end up doing things like this. We have global layout listeners. We end up having to attach listeners to the view tree observer for giving us notifications of when our layout params actually stick to the view, right? So it's asynchronous, essentially. This is something we do and we have to do, and it could get tedious and complex depending on how complicated your hierarchy is, how many animations you have, and how rich your UI is. So we can then say like UI is reactive and it's asynchronous. Now, because we sort of made these points, and we kind of illustrated that MVP might break down if your app is too complicated, right? Could this be because we're not really embracing the true nature of UI? Could this be because MVP is trying to sort of move away or like reject what UI really is and what it should be handled as, right? So components need to be choreographed and coordinated with one another. There's no way to get away from this, right? That is what UI is. And because of this, we need to really embrace that UI is reactive. We need to embrace that we can't necessarily say that our simple approaches can scale well, because if our simple approaches don't embrace this concept, they will not scale, they will break down. Android Framework API, as we saw, can be asynchronous. The UI, another important thing, and a lot of people like just starting out with Android, and I remember coming to terms with this, that UI needs to be able to handle, survive, and manage, or manage itself during configuration changes, and that's something that's super important. for a high-quality app, right? Now, Marcus is going to talk about this stuff.
So ViewModels, just to have an idea, how many of you know what ViewModels are, what they do? Cool. We're not going to go deep. This is not a deep dive talk about ViewModels. We're going to talk about them very quick. So just to give an introduction, ViewModels solve the need of handling UI cross-configuration changes. It survives longer than the lifecycle that we have for fragments activity or your lifecycle owner. It allows to form a reactive bridge between your core of your app and your UI, and simplifying your code, making your UI just having to react to some stuff that are coming from your core. And it's bound to lifecycle activity of a fragment. Like I said, we have so much to talk, so we didn't have time to talk about lots of in-depth things about ViewModels. If you want to know more about ViewModels, we highly recommend the talk from droidCon New York by Lila. It's really good. She really goes in depth on it, and LiveData too. So you should definitely check it out. So let's talk about LiveData. Bound to lifecycle, parent lifecycle owner, fragment activity. It can be also your custom view if it's a lifecycle owner. It can be used to form connections between UI components too that need to be interactive, and we're going to be talking a little bit about that. And it acts like a behavior subject from RxJava. Does everybody know what a behavior subject is? Could people tell me, raise their hands? Behavior subject, RxJava? Well, good, because we're going to explain a bit how LiveData works. It's important to know how values are emitted and how subscriptions are handled, because you may not want the behavior that the LiveData has. So let's take a look at this here, where the line on the top is the LiveData stream. And on the bottom, I have an observer that is subscribing to that. Once a value is put on the LiveData, that value is sent to our observer. If I put another value on the LiveData, if I update that value, it is again sent to whatever observer I have. But then now let's look what happens if another observer comes in and subscribe to that LiveData. Now, at this moment, I'm going to get the old value that was sent before, and then the LiveData is going to react to that. That observer is going to react to that right away. And then if I ever send another value, it's going to send to both of them. It's really important to know how this works and how this relates to behavior subject, because you may not want that. You may not want at some point on your UI, depending on what you're using, what you're doing, if you don't want to add the complexity of using RxJava and you want to try to solve most of your problems with LiveData, you may not want to have it behaving like that. Maybe you want it to behave more like this, where it behaves more like a published subject, and then you can do some workarounds to make that happen. Jose from Google, he posted on GitHub the other day, event LiveData, which is a LiveData that actually doesn't do that and makes sure that it's only propagating the new values that are being set down. And we're going to see how this can be important very soon. So let's talk a little bit about transformations. It's like a LiveData version of operators for RxJava. And out of the box, we have map and switch map. We're just going to go through them very quick. A transformation map is a one-to-one static transformation. So let's say here we have a user that it's actually a mutable LiveData. We want the birthday. We just want to subscribe to the birthday. We just want to have it, and we want to have it formatted, while the user only have a string. So we can apply a transformation to that user LiveData and get the birth date, which is a string, and pass it to a method that is going to return it parsed to a date object. Then the transformation.map at the end is going to return me a LiveData that it's actually a LiveData of a date, and then I can just subscribe to the birthday of that. And when the user changes, my birth date LiveData is going to emit the birth date formatted, and I just need to know whatever I have. Switch map, it's a more dynamic transformation. So let's say on the case that we were showing at the beginning, we get an ID from the index of the current photo, but we need more than just get another property from that object to emit it on another LiveData. We actually need to get that information and send it to the core, so the core can go to the database or maybe to the backend and go look for that picture, and then you have a whole different stream. So you may need a new LiveData So the switch map allows you to do that too. It also unsubscribe to whatever was subscribed before. So it's a very good use case of map and switch map. So let's talk about UI as a network.
All right, so everything Marcos just mentioned kind of resembles sort of building blocks that can be put together to form a network. And that network is essentially what we're going to be treating the UI as. So let's consider a scenario where you have an activity with several fragments. So typically at a high level, what's going on is your fragments have to communicate with one another and with the activity. And the components and the channels of communications themselves are all bound to the activity's life cycle. So we start with an activity that's stopped. The moment the activity started, we have the components of the app. They're there, the channels of communications have been established. And from a high level, it really does resemble a network. Now, because ViewModels and LiveData are lifecycle aware, we could take advantage of that and use them as the building blocks for the network. So in this case, let's say each of our fragments is represented by a view model. So it's a one-to-one relationship, and that's typically what you would kind of do out of the box. You would have your fragment, and you would try to model a view model that handles presenting and configuring everything in that fragment, right? So let's look at this a little deeper. Now, if you imagine your fragments having complicated hierarchies, complicated view group hierarchies with many children, and you still keep that one-to-one mapping with the view model, you're going to be in the same boat where your view models are going to get monolithic. Your view models are going to be doing way too much. So it's going to resemble the same problem that we had with MVP, views and presenters, right? So this one possible reason for this could be that your view models contain live data, like several different kinds of live data to handle the presentation to the fragment. So it could be that your live data is sort of very granularly trying to update things in your fragment. All right, so just to illustrate that point, right? We have a fragment, we have a view model. Let's say a fragment has about like 5 child views. Let's say that in order to present and choreograph these child views, we need about like 4 live data in the view model. And let's see how we would form these connections, right? So they might be one-to-one, they might be one-way, they might be two-way. But the point is that as you start adding more views to the left-hand side, you're probably going to have to add more complexity to the right-hand side. So can we really simplify this? There's got to be something here that we can group together or distill or generalize. So if we like zoomed out and took a step back at how UI interactions and configurations and updates happen, you could say that in general, UI and interactions, they kind of resemble transitioning states, kind of like, for example, a game. And, oops. Yes, anyway, so this is an example where we're looking at the same screen as before, and we can sort of click on the buttons and have changes happen on the UI, but this time we're not treating these changes as microscopic changes on each of those cells. We're going to treat them as a whole, and we're going to say that each interaction causes a new state to occur. All right.
Let's see how we can use live data together with states to have a more well-organized code for the UI. So right here, we would have, let's say, a state live data. And when I click here, it emits a state. And then I just react to that state. If I click here, then that state changes to a second state based on an action, which was the click button. And then when I click the other button, which is another action, I have a third state, the state C. It's important to say action in there because we will be talking about that right now, and we're going to give a very fast introduction about state machines, because that's how we're using it together with LiveData.
Absolutely. Okay, so just sort of talking about like state machines in general, and this is a very like common concept. It's something that exists in the world. So the way we wanted to treat a state machine, or the concept of a state machine for our purposes, was to keep it pretty simple. We wanted to say that a state machine is basically represented by this equation where a state, when given an action, outputs a new state. So we wanted to pick this pick a simple version of this because state machines are really a realization of the fact that your entire system is reactive, right? And since we've established that UI is intrinsically reactive, this could really help us out. So whenever we sort of come across certain UI elements or certain experiences, and if we're able to behaviorally and visually disassemble them into a series of states, actions, and side effects, then this way of thinking really comes in handy. All right, so what are actions, right? So we said that an action is something that a state can consume to produce a new state. So in this example, what we're going to be doing is an action is going to be basically any interaction that the UI that the user can perform with the UI. Maybe the user can click on a button, drag a button, etc. So let's take an example of a fragment with a couple of buttons, a couple of listeners for those buttons, and what we're going to say is for button 1, when you click on it, we're going to codify that interaction as an action called button 1 click. Similarly, if for the drag listener, when the user performs that interaction, we're going to codify it as button 1 drag, and same for button 2, right? It's going to be a button 2 click if you click on button 2. Let's see what side effects look like. So a lot of the times when we think of like designing, architecting UI, there are cases where we will have to perform certain tasks that sort of act as like a behind-the-scenes update, where we might want to update the store when the user submits something. We might want to make an API call, or in general, like start a background task. So we might want to do certain things as a result of the UI interaction that don't necessarily correspond to something on the screen that the user can visually see. So for that, we're gonna model those concepts, and we're gonna call them side effects. All right, so let's see what states and actions really look like if you were to implement them in Kotlin. So keeping it super simple, we're going to model this as a sealed class, and we have said that a state is something that can consume an action to produce a new state. Let's start with an example of a state called state A, and this state basically extends from state, and it needs to implement the consume action function. And here, basically what we're going to be doing is looking at the action, examining the action, and then deciding what state should come as a result of the current state having consumed it. So let's see what happens when, in this state, you click on button 1. We want to say that when you click on button 1 from state A, you go to state B. Similarly, when you click on button 2, let's say that we want to go to a third state called state C. Now, we talked about side effects, right? So this is one possible way you could model this concept of a side effect with your existing sealed class of a state. It's the same sealed class as before with the extra addition of a nullable side effect. And there's cleaner ways to do this, but just wanted to use this to illustrate the example. And state A is now going to implement consume action. Just as before, a button 1 click will make state A go to state B. A button 2 click now will still make state A transition to state C, but we'll have the added effect that there's a side effect, and we're going to codify the fact that we're going to update the store. We're going to call it side effect update store. And this can be a sealed class of different side effects that you want to model all your tasks or anything that you want to start up that happen in the background when the UI interacts with things. All right. So now I'm going to hand it to Marcus, and he's going to talk about how you transmit state updates using LiveData.
Okay, so let's imagine a whole hierarchy of views and fragments and containers. Let's say we have this container, which could be a view group, could be a fragment, could be activity, depending how you like it. I have a child view here, another child view, and those have their listeners. And when we talk about listeners here, we're talking about click listeners, drag listeners, like we mentioned before. And then they have their own, we'll translate them into actions, and those actions are going to go through a state LiveData. Which is going to consume those actions, and then it's going to return a new state, and it's going to just publish that state out, which the container is listening to, because as a good citizen of a view model and a view, your view is only listening to the view model, and it can now handle that state, and then maybe change the view, maybe deactivate a button, activate another button, or popping up an animation, or anything like that. So let's see here what the state LiveData would look like. We have here the current state, and we have the action consumer. We have a new action, a click. We send that to the state so it can be consumed. It's consumed, now change the state, and then we just spit out that new state that you can react to. If we look in a code, for example, we have this flow view model here. We can have a state transitions, which is a mutable LiveData. It starts with the state A, and then we have the method update state that is called by the UI to perform an action. Here, we can just get the current state, which is the state transitions value, and then we can perform the action there and then change the state. Let's see what it looks like as a side effect. And this is a very important part, because side effects are supposed to happen only once, theoretically, depending on what you're using, but they should only happen only once. And that's where it's important what we showed at the beginning, that you may not always want a LiveData to behave like a behavior subject. Sometimes you want it to behave like a published subject, and that's where, right here, you may want it to be a event LiveData or something like that, instead of a LiveData, which is only going to emit once, and it's not going to emit the same side effect again if you ever change the configuration and you subscribe to it. You don't want the side effect to happen again, because it already happened once. But it really depends on how you're architecting your code. So right here, the side effect could very well be a transformation of that state transition, and then we can either apply a side effect right away. If we have to update the database, we can right away update the database. If we have to do an API call, we can right away API call. Or if your side effect does any changes to the UI, you can actually expose that side effect to the UI and just listen to whatever is important for you. So here is the UI code. In this case, the fragment. You get your view model here, and then on your view model, you can get the state transition, and then you can observe to it. And then right here, you can have a switch statement that will just check which state is the one right now, and it's going to treat whatever you have to treat for state A, whatever you have to treat to state B, and state C. Another example here is how we can update the state. We have right here a button that has a click listener, and then right there we can just pass a flow view model, and we can call update state. We'll pass that button click, and then at that moment we'll consume that action, and by consuming that action, we're returning a new state. Here it's how we can use that to handle a side effect. You can subscribe, your view model also expose a side effect. If you ever need to do something in the UI, do an animation or anything based on a change of state that happened, you can subscribe to the side effect, and you can handle it here. But most of the cases, maybe your side effects can be handled by the view model itself, because it's maybe a call to the API or data store or anything like that. The beauty about that is because it's really like, it really allows you to separate concerns. Like, if you need to like have any information on side effect, you don't need to like have any ifs. You don't need to have any verification. If this, then do that. If this, then do that. All you need to do is actually just check your state and just make sure that you're subscribing, that you're reacting to that state. It makes your UI code very clean, and you can really see what's going on there if you're ever editing or doing any changes to that code. I'm going to pass for Tasha.
Cool. All right, so let's look at an example. Let's take Tinder chat as an example, and let's look at how we can apply these ideas to it. So this is what the chat currently looks like in Tinder. And right here you can see that nothing is activated, nothing is focused, it's just static. So let's move down to the bottom of the screen where we have a GIF button and a Bitmoji button. Now these two buttons, when the user interacts with them, they will enable the user to send either GIFs or Bitmojis respectively. All right, so let's take a look at what this current configuration of the screen can be codified as. So keeping in mind the state plus action equals new state, let's call this configuration of the screen as text input unfocused. And the reason we would want to choose that specific set of words is because if you were to click on the edit text right here, you would then be able to type in a message and send it to the other user. So it's text input, but in this case, it's unfocused. Now, we just want to sort of illustrate what happens if you click on the buttons that we talked about earlier. So let's say you're in this state, and you click on the GIF button. Now, the configuration of the screen changes to reveal the keyboard and a carousel for your GIFs. This state is something we call GIF input focused. The edit text is clearly focused, and we are able to view a carousel of GIFs. Let's see what happens when we click on something else here. GIF input focus state is our current state, and then we click on the Bitmoji button. Now the screen changes considerably. There is no more keyboard. The top carousel has disappeared. There is now a bottom carousel that is revealed, and this is what we want to call Bitmoji unfocused. So now we have a third state. Let's see what happens when we are in the third state and we come back and click on the edit text. This, again, considerably changes the configuration of the screen. We now have the keyboard. Both the buttons are inactive, and we are essentially in the text input focus state, and right now, the user will be able to type in a message and send it. And let's look at the last interaction, which will bring us back to the first state that we started with. Let's click on the back button here. That's going to clear focus on the edit text, bring down the keyboard, and we're back to where we started with the text input unfocused state. Now, if you were watching this like a hawk, notice this area right here with the green box. As we transition through the states, the configurations of the buttons themselves change. So at times, one of them is active, and at times the other one is active. And sometimes both of them are inactive, like this case. So what we want to really do here is you could either handle this by saying that you want to set one button to one state and the other button to the other state, and you can do that granularly, but it could get super complicated if you have more than two buttons. So what we want to do is we want to group them together, and we want to treat them as a sub-state machine and handle sub-states.
Exactly. So one of the ways you could do that, you could create a method that is going to be like, for example, deactivate buttons or activate buttons. And then depending on the state, you're going to just keep calling those methods. But then you're kind of somehow bringing some sort of logic to the UI where it needs to know what is the other state and all those stuff. Why can't we just deactivate and activate the buttons without even caring about if else or about what is the current state of the whole screen? That's exactly what we're trying to do here by using a substates with custom LiveData. So let's imagine this. We have the state transitions. And then we have a text input unfocused, text input focused, and all those four. And then when we are in a certain state, the buttons there, the substate, are all inactive. And when it's text input focused, it's still all inactive because we haven't touched them. In this case, then the GIF button is active, and the other one is Bitmoji button is active. Here, if we look at the code, what we could do is we could have actually a custom LiveData that has a property that is also a LiveData called button group substates. We can then just observe to that substate and just handle it. The beauty about that is because one is completely separated from the other in the sense where you don't need anymore a method called deactivate buttons that is going to be called many times on your code before, depending on which state you are in. You just need really to care about deactivating or activating or changing them, and then your live data, by using transformations, will be able to know which one to call. So if we come here to state transition, we can extend a mutable live data or live data itself, and we have the initial state there, and then we have the method update state. But then we also have here a property called bottom group substates. This is another live data that actually is using the transformation to verify which state I'm in. Because when we are doing a transformation into a live data, we get updates. It kind of becomes like a proxy. And then you can check, okay, text input focused, then the bottoms should be all inactive. Also, when it's focused, all the bottoms should be inactive. And in this case, it's a GIF bottom active. In this case, the Bitmoji bottom is active. What's really exciting about this is that by writing your code this way, we just go back for a second. The really nice about this is by writing the code this way is that you're removing even more responsibility out of your views and making sure that they're just really, really reacting to different states, and your code becomes very easy to read and very sustainable. View model live data and states. Simplifies interactions between child views and their parents, ensures that all UI elements behave predictably, like even across hard to test UI interactions. When you're reading that code and you see that you're subscribing to some sort of states or substates, and you're just handling on it on a switch, you know exactly where to go when you need to change something or when you need to do something new when you're in a new state. And then it will survive across configuration changes because we are using live data. Before we talk about taking this further, we have to realize too that there is no secret sauce here. We're using LiveData view model, but there's nothing stopping you from using RxJava with auto-dispose inside of your view model. This is really a thought experiment. It's it's a pattern that can be used in many ways. That's why it's not a framework either, because your needs can be different from app to app. So if you just follow the pattern, you can really adapt it to whatever needs you have. So I'm gonna pass to Tasha so she can talk about how can we take this even further.
Cool, awesome. So there is a lot we can do to build on this kind of basic idea, right? So one of the things we can do is, so far we've been talking about containers as fragments, but if you are averse to fragments, or if for some reason you really don't want to use fragments, you could still use view group containers and have the same pattern applied. However, you might be thinking, how would you get a view model and a live data to bind to your view group? It's easier to acquire view models in fragments. But turns out that the Android developers page has a solution for that. Data binding. So this is a topic in and of itself, and we could probably take a whole 45 minutes just to talk about this. But data binding and architecture components work seamlessly together. And what data binding will enable us to do is to directly bind view models and live data to view groups in their XMLs using binding adapters. This basically eliminates the limitation that you must have fragments. It also enables you to make sure that you use this pattern for even minute sections of your UI. And those minute sections, like button groups or groups of several views, they don't necessarily have to be implemented as fragments, right? It's easier to think of them as view groups containing other regular views. And finally, as we saw with the state transitions custom live data, you can sort of really fine-tune and basically sketch out a really good custom live data to suit your needs and implement this basic idea of treating UI as a network of states and having a live data broadcast these states and having various components being able to bind, react, and adapt to these state transmissions.
Yeah, just make sure that if you're doing that, you're not keeping any heavy objects on your value of your live data, because then it's going to be problematic to your memory. But you could take this further by doing customizations. Yes. And also, if you think about it, if we go back to the first example that I showed, where when changing pictures, we change the preview of the information. You can adapt this idea to whatever you need. For example, in that case, there is such a big hierarchy they're so separate from each other that it made even more sense to just have a custom live data that it's bound to, by using Dagger, it's bound to the activity scope. And we just inject that live data directly on the view, and one reacts to the other. So the custom live data has properties that actually represent what we're showing on the view, and then we're just subscribing to it. Like in that example, we didn't put it on the slides because we thought we wouldn't have time. And it's true, we only have 5 minutes. But in a high level, if you think about it, we could just have a live data that have properties like index and has properties like previews. And depending of the changes that happens on the index, you can do a transformation to that index to show the right preview. And then your code on your view just have to subscribe to that preview live data, which is a property of a whole live data, and that's just show the current preview. You don't even need to care about the order. If you just hiding and fading out a current preview and showing the new one, you don't even need to care about the order. So we can experiment. We can do experiments that in this country, we're showing this first, this first, this first. In this other country, we can show this first, this first, first. And this can be completely configurable on the back end because my UI doesn't care about the order. My UI just cares about when it has to show them or not. So that's it. Thank you very much.